Welcome to this PalmSens webinar. I'm Lutz Stratmann, and today I will show you some things about MethodSCRIPT. I'm not alone. I will introduce you to the company I brought in a minute. But first, I would like to give that minute to people who are going to be maybe not 100% on time, right? We know that not everybody manages to be always perfectly on time, but to use that time, we will make a small poll with you because we would like to know, why are you watching this? What are your expectations? And we might adjust the Q&A session that is at the end of this webinar, then according to the results of that. So we're starting a poll right now. Right, and the poll is running. And yeah, we would love to know why you're here and what you would like to learn from this webinar. I mean, we have, of course, a program for you. And yeah, we just wait another minute, and then we will begin with the introduction. We will have a demonstration, including showing code and the explanation what it does, and some experiments. And then there will be a Q&A session with experts that I'm introducing in a minute to you. Oh, very important, if you do have comments or questions already during the webinar, you can write them into the chat section of your interface, and we will read them during the webinar, but most likely we will answer all questions at the Q&A part, during the Q&A part that's towards the end. Okay, so welcome again. I'm Lutz Stratmann. I'm an electrochemist, but today we're going to talk about MethodSCRIPT, which is a scripting language. So this is about programming, which is, well, not my forte. I'm occupied looking at electrons and ions and metal complexes. So I brought myself some, reinforcement and some support. And the first person I would like to introduce to you is Hielke Veringa. He is one of our software engineers at PalmSens, and he's an expert for MethodSCRIPT. And, well, he will show you more about this. And as usual, I brought for the webinars my colleague Adi van der Berg with me, who's going to be your voice, your voice in this webinar, because when you write in the chat, he's reading it, maybe replying directly to you, and afterwards he will make a selection of the questions and present them in the Q&A session to us. Okay, so this is what's going to happen today. I will first give a short introduction, a short presentation about MethodSCRIPT. Then Hielke will go with you through some examples, how to use MethodSCRIPT. And then with Adi, we will answer some questions for today. Yes, I think I covered everything for the introduction, and we can immediately get started with the main topic of the webinar. Oh, very important remark. In case you feel things are going a bit quick and you would like to re-watch this webinar later, you will receive a recording of the webinar. Everybody who's registered for the webinar will get a newsletter containing the link to the recording of the webinar. Okay, so let's get started with the introduction to MethodSCRIPT, because I can imagine that most people ask immediately, okay, what is MethodSCRIPT? Like, are we not going to talk electrochemistry? No. This time we're talking about a scripting language for conversations between the software and the instrument. So how the software gives a command to the instrument that it then executes. We have made this scripting language to make it easy for you to design complex tasks that are mixtures of experiments, and we made this programming language human readable. Which means, well, it's written in ASCII, and it makes it also easier for you to modify it when you can read what's actually in the script. It supports all electrochemical techniques that are usually supported by our instruments, so it depends a bit which instrument you've chosen, but all the techniques are available. Right, as I said, you can combine multiple techniques, and you can even manage this way to basically create functionalities in the instruments that are otherwise not there. And we will have a few examples of functions that won't work, that are not presented to you in PSTrace, but easily done in MethodSCRIPT. Right. So MethodSCRIPT will make it easy for you to integrate our PalmSens potentiostat modules effortlessly in your hardware or setup. Yeah, so it should make it easy for you. And as I said, I'm not a programmer, so I just have a very high-level view. So I'm just, yeah, so a rough idea of how this communication works. And it's basically like you see here in this animated GIF. So the host, which is usually a computer, a smartphone, or other processing device, is checking if the potentiostat module is there and ready to receive the method script. And the potentiostat module is confirming this. It receives the method script, which is, as I said, a human-readable code. And then it confirms that everything's all right, and it starts the measurement because it knows exactly what to do with this piece of code and can perform the measurement. Right. When you start with MethodSCRIPT, and you're, like me, not a programmer, you're just a programming enthusiast, let's say, you might want to start with what, well, my professor called it chaos programming, which is like taking a working code and tweak it till it does what you want to do. And you can do that easily. Again, in this GIF, you can see something. In PSTrace, we have a button called Show MethodSCRIPT. And with that, you can open the MethodSCRIPT window that then shows the code that's used for performing exactly the method that is now in the method editor. Right, you can also then copy-paste that to the clipboard and enter and edit to the code that you're writing, or you can, inside MethodSCRIPT, use it with a MethodSCRIPT sandbox and editor to, well, test immediately your newly written code in MethodSCRIPT in PSTrace so that you get it visualized in PSTrace. We do have more examples. You don't have to use PSTrace. We have more examples, coding examples on our website, how to use it on different platforms. It's free to download, so feel free to try that. So multiple of our devices are capable of working together with MethodSCRIPT. We do have the EmStat Pico, which is our small potentiostat module. We have the EmStat Pico Core, which is the chip that the EmStat Pico is based on. We have the Sensit series, the Sensit Smart and Sensit BT. Both of them are based off the EmStat Pico. So this is like one family of instruments that all work with MethodSCRIPT, but also our newest edition, the housed EmStat4S and the EmStat4M that use MethodSCRIPT for as a scripting language. So you can easily also use it with a housed version like the EmStat4S to make more complex experiments, or with an OEM version like the EmStat4M to write software for your own application. Today, we're going to use the Sensit BT. I put here a red circle around it so you know which instrument you will see later. And we're going to use the EmStat4M Development Board, which is an EmStat4M that is already mounted on a development board. Development boards are great because they make it easier to play with hardware development because all the connections are available. Your EmStat4M is safely mounted onto this one, so you don't have to solder directly on it. And you have a few extra features. If you want to know details about this, just visit our website, PalmSens.com, go to the OEM section, and you will find more details about these instruments. But now I would like to get to, well, the main part and main attraction, which is MethodSCRIPT. And Hielke, I think it's time for you to, show the people what it can do.
All right. So we're going to be showing a few examples of how you create your own MethodSCRIPT. We're going to be using PSTrace. So we're going to generate a script or a measurement in PSTrace, then generate a script from that. We're going to be using this little box over here, which is, we're just using this as a test cell. So this emulates your chemistry, but it's just electronics. For most of the measurements, we're going to be using the redox sensor, which is also available on the dummy cell, the little blue PCB that is also supplied with most of our instruments.
Yeah, it's for those who have the dummy cell in front of you, that's the WEA.
The reason we're using this is because if you do an SVT on this dummy cell, then you get a nice peak, and it's going to become important later that we have that peak. Okay, so let's switch to PSTrace. And here I've already made a measurement for the SWV. We're going to be using this as our standard method that we're going to be using for the coming experiments. Again, this will give a nice peak on the cell that we've selected. We've also turned on saving on internal storage because the Sensit BT has internal storage on the board. So let's just run this measurement. So this is how you would normally just do a measurement in PSTrace. And there you go. There we have a peak. I'm not going to go into why there's a peak here, but we're going to use that later. Now we want to add some extra things to, well, first I'm going to show we do indeed, let me delete this measurement just so we know we're actually loading something, and then we're going to load the measurement from the onboard storage.
So the difference to the normal load data command is just that this is now loading from the internal memory of the device, right?
Yes. So I could have done this measurement in the field and without any PSTrace attached, and then I could load it later using this feature. Yeah. There we go. We can load it from the disk. Now we're going to add some extra features to it using MethodSCRIPT. So these are things we can't normally do in PSTrace. To do this, we first generate a script like Lutz has showed before, and a button that wasn't shown earlier is here in the bottom right. There's a open in editor that will take you to the MethodSCRIPT sandbox. This is just an editor that you can use to edit MethodSCRIPT. So this is what the script looks like. Just for our convenience, I've made a new script already ahead in time that has some more comments and some more explanations. So I'm just going to load that. So this is the same measurement, but with some extra things added. The first thing is we're going to hibernate for the first thing we do in the script. And this is so that if we start the measurement, it doesn't start immediately, but we can start the measurement by pushing a button on the Sensit BT later on. The rest of this bit, the first bit here, is just initialization. I'm just going to skip over this just because it's a lot of code and it's not that interesting to explain right now. Most of this is generated by PSTrace. This is the interesting bit here. This is the measurement we're actually doing. So measurement loop SWV stands for measurement loop square wave voltammetry, and these are the parameters that we set in PSTrace. Here we've added an I2C temperature sensor. We're going to read out the temperature from an I2C sensor. This is just one of the things you can do. In MethodSCRIPT, we've exposed the I2C bus in MethodSCRIPT. So in theory, you can connect to any I2C peripheral and use that in your script. Temperature sensor is just a nice example that we are using right now. So here we're reading out the temperature sensor itself. Then this bit is converting the value from the temperature sensor, which is just a bit value, to a value in degrees Celsius. So we have to do some calculations from the output of the temperature sensor to bring it to degrees Celsius. The last bit of the script is just us sending the data to PSTrace or any other host that might be listening. The sweep potential and the current output are just the normal output of square wave voltammetry. And we've added a temperature to that, so we're going to be able to see that in PSTrace. All right, so we're going to run the script now. So this should give us the same peak, except it's not going to start right away because we said we have to push a button first. You can see the button here. So we push this button, and now you can see the cell collect coming on and the measurement is starting. We've added a little bit of noise just because I was touching the device in the measurement, and it's quite a sensitive measurement. But otherwise, we have the same kind of peak here. Yeah, so now we go to, now we have to show the temperature as well. So this is the normal measurement, and this is the other variable that we've added. PSTrace has interpreted this as it's another type of value, so you want it to be in a different graph, because this is temperature, while here we were measuring current. So we can see here that we see 26 degrees of current, and it's going up a little bit because the device is busy, so it will heat up a little bit.
Just out of curiosity, do you actually have examples for other type of like sensors or typical connections for an I2C connector?
We have a few examples in the MethodSCRIPT description document. We have an example for an I2C real-time clock, I believe. I'm pretty sure you can have things like analog switches where you can use them as a muxing device, or you can have a little DAC on there. There's many different types of I2C sensors that you can have on that bus.
DAC is digital analog converter.
Yeah, so
okay, yeah.
It's to output an analog voltage.
Okay.
All right, let's go to the next measurement. We're going to take out the things that we just added. Now we want to add in some different features. This script is, we're going to show that you can do calculations in the script. So we're going to do the peak detection here, simple peak detection, and then we're going to draw some conclusions out of that peak detection. If the peak is higher than a certain value, then we're going to say, oh, we've detected something, and we're going to turn on a red LED. And if there's no peak, then we're going to turn on the green LED, because in this case, let's imagine that that's a good thing. So let's go towards the script. Again, I'm going to skip over all of the initialization here and jump straight into the measurement. Again, it's the same measurement, same parameters. We're going to expect the same peak. But instead of sending the data straight away to PSTrace or any other host, we're now storing the data in an array just so that we can do some operations on it later. This next section, we're determining the maximum value and the minimum value in our graph. This is our very simple way of detecting a peak. For a lot of applications, you might need a little bit more advanced peak detection. There are certainly better ways for a lot of applications. But we're just trying to show this as an example that you can do this kind of thing in MethodSCRIPT. Then we go to the next bit. This is just us sending the data that we've measured and the data that we've calculated to PSTrace. The first two are just the normal measurement values of the square wave voltammetry, and then the second two are the minimum and the maximum value. This means we're going to see them in PSTrace. We'll show what that looks like in a bit. This last bit here is we have a variable with the maximum. So we can just say if that variable holds a value of more than 2 nanoamperes, then we turn on one of the GPIO pins. Otherwise, we turn on the other GPIO pin. In effect, this turns off one of the 2 LEDs. So if our peak height is higher than 2 nanoamperes, we're going to turn on the red LED. If it's lower, then we're going to turn on the green LED.
But we're not going to do that with the Sensit BT.
We're not going to do this with the Sensit BT, correct. This test, we're going to connect to the EmStat4 dev board. You can run more or less the same scripts on both. Some of the GPIO pins and other hardware-specific things might be a little bit different, but the script itself should run on both devices.
Right, but the pins are here nicely available on the development board, so you could easily solder the LEDs to it, right?
Yes, and this is what we've done. So here you see the development board with just a normal EmStat on it. You can take this off if you want. It's just a normal EmStat4 module. What we've done is on the breakout board, we've connected a multicolor LED. So we can, by turning off the pins, as we've seen in the script, we can turn on this LED to different colors. All right, so let's run the script that we had. see that's still there. Yes.
You still have the test circuit that you previously had connected.
It's again the same test circuit. Yes. We're going to start a new measurement, just override the old one. Because we're not sending the data straight away, we're not going to see data straight away. We're going to have to wait until the measurement is completely finished until we can see the results. And there we go. So what we see here is the previous graph that we've been seeing in all our other measurements, and we've also got the maximum value and minimum value that we've calculated in the graph. And you can see that the LED has turned red because this peak height is higher than 2 nanoamps. So the difference between the min and max is more than 2 nanoamps. Okay, so then what happens if there's no peak? I'm just going to input a fairly high resistor in this, which is in an SWV is just going to result in a constant current. We're going to overlay this over the previous graph. Again, we have to wait about 16 seconds for the measurement to finish. And this is the new measurement. You can see it's mostly a constant current, and the peak value is definitely not higher than 2 nanoamps. And so we can see here that the LED has gone green, indicating that we haven't detected a peak. Okay, that's all for this example.
But I mean, this is again an example, as you said. So you could have other things connected than LED. You could have a different feedback system. You could have, I don't know, like an app that gives you then immediately a feedback about your result.
Yeah. We've just used the LED as a way to provide feedback to the user. You can do this in many other ways. The point of MethodSCRIPT is to make everything flexible for the user. So these are examples of things you could do.
Yeah. So maybe just to summarize what we have shown up to now. So you have seen how you extract a piece of MethodSCRIPT according to the method that you're performing in PSTrace from PSTrace. So that, well, in PSTrace you create your MethodSCRIPT, and also how to change it in PSTrace and use PSTrace to visualize it. So that makes it easy when you start working with MethodSCRIPT. You've seen some functions like reading the I2C bus, and this way having additional sensors that you can connect to it, or signals. You have seen how the instrument can hibernate very easily in MethodSCRIPT, right? Oh, maybe you can say something about what is exactly the hibernation. We've just seen the instrument doesn't do anything till you push a button, but why is hibernating interesting?
Okay, so hibernating is a way of reducing the current that the device is using. This is mostly applicable to OEM customers or devices with a battery in them. If you're just connected to USB, it's not that useful. This is just one of the ways you can wait for a trigger. You could also just wait for a pin to toggle. You can just request the value of a pin and wait until it goes into a certain state.
Mm-hmm. Yeah. Okay, so we've seen the hibernation. And then in the last example, you have seen a very simple peak search with, well, again, a very direct way of getting feedback from your measurement, right? So this way, you could have, even without seeing the result, you just get the color of the LED, and you know if you would get a green light or a red light. I mean, this could be, for example, be a toxicity test. Let's say it could be a test for Legionella in drinking water, for example. And if you exceed a certain value, you do get the red light and you should not drink that water. So just as an application example. And I think this is already what we wanted to present from our side. But now, of course, comes the exciting part where we have interaction with you. And that's the moment when I will ask Ardi. Ardi, do we have questions?
Yes, we do actually have 3 questions waiting. So that's very good to hear from the audience. So thank you all. Let's start with the first question, Hielke. This one is for you. So you have explained about the Sensit BT and that you can run a measurement and you can save the data on the device itself. Now we've got a question. Can you also do a measurement or even multiple measurements and not save the data on the internal memory?
It depends kind of what you mean. As long as the device is running, you can store your measurement data in RAM. It's basically what we've been doing just now. You need some kind of trigger to send, so that the script knows to send the data to the host. So you need a trigger that the host is there to receive the data. But if you have that, then yes, you can wait until you connect it to a computer to actually send the data to the computer.
Yeah, but if you perform a measurement, but for example, you need 3 measurements, and the first 2 you can delete. You don't need them, but you still need to perform 3 measurements. Can you do the first 2 and not save this data in the internal storage and do save the last one?
Yes, you can open a file at any point in the script, and the script output from that point will be saved.
Oh yeah, that's very useful.
A second thing you can do is just open a file at the start and just not send any data points, and that means the data points won't be stored.
Yeah, until you reach, for example, your 3rd measurement, and then you can save the data. All
Exactly.
right, that's. I think that answers the question very well. Then there is another question about the real-time clock that there is available. Is there any example that you know in the documentation where you've shown how to use this real-time clock?
Yes, in the MethodSCRIPT documentation, there's a section MethodSCRIPT examples, or
I think it's on the end. Yeah, or at the end.
It's at the end, but there's a specific example for the RTC that's on the EmStat Pico dev board.
Right. For all those that want to download the coding examples, you can go to PalmSens.com. Then on the top, you see the tabs that say Research, OEM, and Corrosion. You go to the OEM one, and then in the menu, you choose Software Development Tools, MethodSCRIPT. And on that website, you can find a button directly to download the coding examples or the code examples. And yeah, I think many of the coding examples are pretty advanced. You can do a lot of things with these. That's also, I think, a good way to get started with MethodSCRIPT. But of course, if you would buy something like the EmStat4M Development Kit, you also receive the documentation. And the Getting Started with MethodSCRIPT document is also available on the MethodSCRIPT website, free to download without any obstacle. Like, it's easily accessible. So feel free to just have a look at it and read it, even maybe before you purchase an instrument that MethodSCRIPT capable.
Yep. All right, thank you. Yeah, Hielke, another question about a timer in MethodSCRIPT. So is it possible to, let's say, for example, we have the Sensit BT again, the device with the button, that you press the button and then maybe in 30 minutes later a measurement starts, and then maybe another 30 minutes later another measurement starts? Is that possible?
Yes. Again, there's 2 ways to do this. If you want to save power, then there's the hibernate function. You can give that multiple triggers. So you can say, wait until you receive some kind of communication. Wait until I press the wake button. That's a certain pin on the EmStat Pico.
Yeah.
And the third one is wait a certain amount of time. So those are already standard features. And the second way, if you don't care about current consumption, which might be a little bit easier, is to just, there's a wait function, and you just tell it, wait 30 seconds. That's it.
All right. That sounds very good. Thank you. Yeah, can MethodSCRIPT, Hielke, also be used as a method to do multiple measurements after each other? So, for example, first an LSV and then afterwards a CA measurement. Is that possible?
Yes, in fact, let's show this in PSTrace right now.
Yeah.
So this already happens in PSTrace. This is just a random CA or LSV measurement. Let's show what the script does. You can see here that it's already generated a script with 2 measurements in it. It's using chrono amperometry measurement as the equilibration time of 2 seconds.
Mm-hmm.
And right after that comes the LSV. So that's intended. That's one of the main features of the script.
Yeah.
So that you can chain measurements.
Can you also do that with repeat loops? Or
Yes.
you have to copy paste?
Yes, and there's also a way to do that in PSTrace. I think that's already in this version, but it might be in the next. Mixed mode will be in the next version, I believe. Yeah. For the
EmStat4M,
EmStat4M,
yes.
Yeah. But I believe you can already do it with multi-step amperometry, for example. No, I need to. So I'm saying loop 4 times over 3 different levels. So then this is the script that you get. PSTrace generates it so that the first iteration is always separate, and then it starts a loop. That's just for technical reasons that we generate it that way. But here you can see, let me zoom in a little bit.
So you could, when you write it yourself, you could skip the first one and start immediately with your repeat loop.
Yes, if that's the intended behavior, then that's exactly what you could do. But there's a loop function here, so you can make any kind of loop you like, really.
Yeah, that's great.
And now, now the difficult question, can you do a loop in a loop?
Yes, in fact, it's kind of already what you're doing, because a measurement loop is also a loop. It's just you can't do 2 measurements loop in each other, so you can't say do 1 measurement loop here and then say inside of that do another one. That's not allowed. But if you use the simple loop command, you can chain them however many times you like.
So I could make 16. A loop that contains make 1 measurement 1 time and then the following one 3 times in a repeat loop, and that's then the whole thing is repeated.
Yes.
Okay. Cool.
Yeah, Lutz, I've got actually a question for you as well, and it's actually 2 questions about the same topic, and there's a bit of confusion. Okay. It's between MethodSCRIPT and scripting, right?
Right. Okay.
So could you explain what are the differences and when to use what?
Right. Okay. So it depends a bit on what you like. On which level are you operating, or how much is your programming skill? You have, of course, PSTrace that just has a mask, and then you use it for a single technique and you perform a single measurement. Right. That's easy. Everybody can do that. Okay, but now you want more. You want to have multiple measurements after each other. And you do the same things that PSTrace can do, just you want to have them more automated. Then you can use the scripting window. So you would, in PSTrace, click on script and then open script window, and then you get this
maybe it's good.
Maybe it's good. Can you show it on the screen? Okay,
I certainly can.
Yeah. So it's just, this is a scripting window, and it works a bit like Lego. This is not real programming, like even I can do it. And so what you do is you have like these measurement blocks that you can fill with methods, and you can basically choose any one, and then you can put another measurement blocks, and you can put a repeat loop, and you can put commands to set a potential, read out the analog input, set the IOs are digital inputs and outputs, like these kind of things you can do with that scripting. So it's already a bit more powerful actually than just the simple interface of PSTrace, because it gives you control, for example, over the digital in and outputs, over the analog output. You can read out the analog input, and you can, as I said, chain multiple measurements in this one. So that already gives you like a lot of opportunities.
And this works for all our devices, right? All our instruments.
Yes. With the next software update, it already does work with all of them.
Yeah, because there's one of the other questions. The EmStat Pico used not to be supported over there, but now it is over there.
Now it is. Yes, EmStat Pico is now supported on the scripting window.
Yeah, and that's PSTrace 5.9, just to be clear for everyone.
Yes, 5.9 EmStat Pico works for scripting.
Great. Yeah.
And then to be honest, then there are 2 more levels actually, because we do have this scripting window in our software. We do have MethodSCRIPT and we do have software development kits. And to make sure I'm not giving any false information, I would like to forward that question to Hielke, what's the difference is between the software development kits and the MethodSCRIPT, and when you would use which one and how much liberty they give you.
Just before we go to the question, I would like to just confirm that the scripting you explained before, right? So there's not MethodSCRIPT, but the scripting. You can't create MethodSCRIPT from there, right? It's not like you have the scripting window and you convert that to MethodSCRIPT.
No, that you can't. No, you can't do something that complex.
No.
Right. But I mean, in theory, what you could do is, of course, is for each of the methods that you have in your script, you could create this piece of MethodSCRIPT and just copy paste them in the editor after each other. Most likely there are some pitfalls that I don't see there, but then just look at the getting started with MethodSCRIPT, and I believe it will be explained there how to chain multiple measurements easily.
Okay, I also have one more comment on this. So one of the things you can do with combining normal scripting with MethodSCRIPT is because you can save a MethodSCRIPT sandbox measurement as a measurement, you can just load that into your scripting window. So you can have MethodSCRIPT inside of the scripting in PSTrace.
Right, we've actually just seen you doing that.
Yes.
When he had opened the measurement blocks and he was loading a method file for this, he was actually loading the same file that he used to save his MethodSCRIPT files. So you could make a custom method file.
Maybe you can show that as well, if it's possible.
Yeah, I mean, it just means the following. If you see it, you can fill this measurement block with anything you like.
Exactly. Yeah, so I've made these 3 measurements that we've used during the demo, and I can just load any one of them. And now I have it in a repeat loop where I can do it many times after each other.
Yeah. So you could make a MethodSCRIPT piece, save it as a method file, and then load it into this measurement block to have this way, like this hybrid of our scripting window and MethodSCRIPT.
Yeah.
However, I think what was wanted, or what the desire was, is you make with that Lego building block set, which is easily to do because it's very visual. You make your script, and then you would, with a button press, turn the whole thing into a MethodSCRIPT, and then you can just use that for coding. I think that was the wish of behind the question.
But the reason that's not possible is because in PSTrace scripting, there's a few things it can do that are not possible in MethodSCRIPT. And the advantage of using just MethodSCRIPT is that you have much better control of exactly what's happening when. So mostly better control of your timing. So those are kind of the 2 more subtle differences between the 2 scripts.
Yeah. Okay. So now back to the question that we asked a bit earlier. What's now the difference? When do I use a software development kit from us, and when do I use MethodSCRIPT? Or do you use both? Or
okay, so the software development kit Lutz is talking about is the C# software development kit. So this uses the same software that PSTrace uses, and so you can have mostly all of the functions that are available in PSTrace you can use in that software development kit as well as a library. It's only in C#, so it's only supported on platforms that support C#. This is quite a few platforms. I think we support it definitely on Android and Windows. And it's probably possible on Linux, but I don't think we support that fully. So that's if you just want all of the complexities of PSTrace and you just want to use the functions already available. If you want full control, and maybe you're working on an embedded system where you just don't have access to C#, we also have open source MethodSCRIPT libraries for our devices where you basically generate a script or make your own script. You put that just in a text file, and you can send that to the device using the SDKs, and then the SDKs will parse the data coming from the device so that you can either plot it or put it in an array and just draw some conclusions from it that way. So the biggest advantage here is that you can use it on any system because it's open source. We have examples for Python, C, C#, I think Android native. Maybe there's a few more.
Do we have a MATLAB one for
Not for this specifically, I don't know. I don't think. Yeah. But you have complete control over everything, so you can easily adapt it to what you need.
If you want to know an example of where we use MethodSCRIPT to kind of transcend what we offer in PSTrace, we had a project where we needed auto-ranging on the working electrode 1 and the working electrode 2 of a bipod. So both of these channels needed to have auto-ranging. And with a smartly designed MethodSCRIPT, we basically created manually an outer ranging for the second working electrode. And this is something that actually is not supported by PSTrace and not supported by the firmware at the moment as it is right now. It was more like a manual way of doing this. And that was for me a point where I realized how much potential it has.
Yeah, nice. I've got a last question. And I think it's also something you've already showed partly, Hielke. Can you perform peak fitting with MethodSCRIPT?
Peak fitting? No, not exactly. You can make your own peak fitting within MethodSCRIPT. It's harder to do than if you were just to write C# or Python, but it's possible. And what we've just done is just a simple peak detection algorithm, but there's no built-in peak detection in MethodSCRIPT at the moment. And there are no short-term plans to do this, maybe at some point in the future.
I mean, but if you have so many platforms available where you can do the programming, I mean, I guess many of these platforms have already like freely available code for some peak finding, peak fitting,
Yes.
these kind of functions, right? Could you, like, if you, I don't know, if you have like the calculation for the fitting, could you run that in the MethodSCRIPT? If you do like handwrite the calculations in there, is it powerful enough for that? Because it's usually like an iteration process. And
it depends a bit on the kind of calculations that you want to do. You can't do everything in MethodSCRIPT. You just have basic arithmetics, no complex numbers, for example.
Mm-hmm.
So it depends on your application, but you can make algorithms in MethodSCRIPT, yes.
Yeah. But I mean, for example, the development board has a port for an Arduino, which is a microcontroller, and an Arduino could perform more complex calculations, right?
Yes, so you're talking about the situation where you're using not just the MethodSCRIPT device, but also a host, be it another microcontroller or a PC. That doesn't really matter in this case.
Yeah.
If you have an external host, then it's almost always easier to do your calculation on the external host. The only reason to do it in MethodSCRIPT is because then you might not need an external host.
Okay.
All right, great. That's all for the questions. I would say they're very interesting questions. So thank you all for asking these.
Yeah, so that was the Q&A. Well, should you wake up tomorrow morning and think, I have really should ask that other question, well, you can still do so. You can reach us, well, of course, under palmsens.com. You can write an email to info@palmsens.com and you will always receive an answer. And yeah, also, if you want to stay up to date, maybe you want to see more of these webinars or want to see more developments for PSTrace, for the EmStat Pico, for the EmStat4, don't forget to follow us on LinkedIn because we regularly post updates about what we're doing and what's coming out and sometimes what exciting things are our customer doing with our products. Or you can also subscribe to our YouTube channel and then you don't miss it when we upload recordings of, for example, this webinar. Right. I think this is it for today. Well, first I would like to say thank you to Adi and Hielke for supporting me in this webinar and well, helping to make sure that all your questions get answered. And then I would like to thank you for watching and have a great day.